here I've got our oil pump assembly. I took it to work and ran it through the sandblaster to get it nice and clean. The sandblaster does a pretty good job, but it does leave kind of a texture on it. So it's not something you want to do on like sealing surfaces. But it did get it nice and clean, and now I'm going to go ahead and hit it with some paint. I saw this from a YouTuber that I watch where he just paints parts the color of metal, and it looks so good. I'm not sure if he cleans them as good as I did, so hopefully mine will look even better. But yeah, we're gonna go ahead and hit this thing with some paint. I'll show you what we're using to make it look brand new. So here's what we're using: Dupli-Color engine enamel with ceramic. Withstands high temps. You know, this thing's obviously gonna get a little warm where it's located. Shouldn't get too bad, but this is a great color, I think. I think it's gonna look real nice when we're done. So I finally got around to taking the cylinder head to the machine shop. I took it to Power Dynamics here in McKinney. They're right up the street from me, and they do a ton of 2J stuff. Of course, they do like super big, fully built horsepower builds. Basically, I was just requesting some basic machining. We had the cylinder that was real banged up, and that's cylinder number 5 here. And so my biggest concern with number 5 is I bought some new valves for it, and I wanted them to clean up the seats because the seats did take kind of a pounding with whatever caused all this damage here. So I wanted them to clean up the seats so our new valves can seal up, and they did that. They went ahead and milled the deck surface. You can see it's all squeaky clean. Gave the thing a good cleaning for me and found several valves that were leaking that they offered to repair for me. In lieu of paying them to do it, I decided I could kind of go old school with it and just lap them myself. I don't think there's any damage to any of the seats. I don't think there's any like real serious pitting, I hope. But what I did was I got home and I got just turned upside down on the table here, and I'm just filling the combustion chamber full of water. So this is a pretty good way to just tell us if we have leaking valves and how badly they're leaking. So this is cylinder number 6 here, and it's dry as a bone on both the intake and the exhaust port. I've got it all logged here. I went ahead and filled up all 5 of the cylinders, of course omitting number 5, which doesn't have valves in it. And really only found 4 valves that needed much attention. So on cylinder number 1, we had a bad valve here, indicating that this one here is leaking pretty good. Drew kind of a meh face right there because I got just a little bit of water accumulation around it after several minutes, but it didn't like drip out of it. And then this valve here. So really just these 2 cylinders here, 6 and 4, were perfect. No water came out of them, left it for several minutes. And 1 valve on 3, 1 valve on 2, and call it 2 valves on 1. So overall, not real bad. What I'm gonna do is, at this point, is I'm gonna go ahead and pull all the valves out of it. We're gonna go ahead and throw some brand new valve seals on this thing just to keep it all sealed up. I'm gonna clean the valves up really well, and I brought home just some lapping compound for like a coarse and a fine grade. And we're just gonna do some old school valve lapping on the cylinders. Then we're gonna go ahead and probably just lap all the valves a little bit, but the ones that need it the most, for sure, will get a little extra attention, and that should seal up everything there. Now, as far as the damage on number 5, if I could go back, I probably would have tried to do something about this before I took it to the machine shop. I know that sounds like an obvious choice, but I really wanted the machinist to look at it and just tell me how severe it is and how big of a problem it's gonna be before I really invest much more into the head. And basically what he said, and this is the second machinist to tell me this, is that really like the thing to do is going to be just kind of like smooth it, just get rid of any high points on it, and just like the cosmetic like pitting appearance to it is not going to have any real effect on the way the engine runs. We talked about he offered a service to smooth it out for me. He said that they offer a service where they weld it up, they build it up with weld and then smooth it back down. But his thoughts on it were, honestly, it's not a super desirable cylinder head. It's not really worth putting a whole ton of money into it. And just him knowing my power goals, said it would be fine to just smooth it out, take the high spots out of it, and go that route. He also said that building up with weld and then filing back down, you definitely lose some integrity from the metal. You know, the weld is not going to be as stout as the original metal was. So it doesn't seem to really make a big difference one way or another. I am just planning to take any high spots off of it. I'm just going to use like an abrasive disc on a drill and just kind of smooth it down a little bit. I've been recording. I've got my little syringe here. I've been recording the amount of water I'm putting in the cylinders, and I'm seeing about 50 cc's. Appears to be the combustion chamber size after milling and everything. I'm not sure what these heads are stock. I think obviously it's around 50 cc's, but that's about where we're sitting now. And I want that number, so I took it on each cylinder to just so I could get an average, because I know my measurement's not super precise. But what I want to do is, after I remove the metal on this one, I'm going to fill it up with water and see if we're within a pretty close overall combustion chamber volume once we're finished up with that. So all of the valves have been lapped, both with a coarse compound and then a fine compound. Everything is cleaned up and tidy. I measured installed valve height, valve stem height, and recorded those numbers here. Looks like everything is pretty well at the 1.5 inch range from the spring seat with the seat spring seat shim installed. We're sitting at right about 1.5. Our total average was 1.498, lowest being 1.488 and highest being 1.507. It's the highest. I wanted to get this data because I have to go through the shims on my buckets, and hopefully I can mix and match them to work with my installed height measurement before I install the cam and measure clearance and all that. So I'm hoping if I have any shims that are extra thick, they can go on the valve that is installed height is extra tall, or extra short rather. And that way maybe I won't have to get any additional shims, but we'll just have to wait and see how that all turns out. My machinist said that cylinder number 5, which would be 9 and 10 here, will probably need different shims, because that's the one that he did the valve cut. He cut the valves on for the new engine valves, but actually they are real close to the average. Here are the numbers here for the intake and the exhaust. And so that's actually in pretty good shape there. But I got the valve seals installed, some new valve stem seals, and I'm gonna go ahead and get all the valves installed with the retainers and the springs and everything for final fitment. I've already wiped down all the compound away from the valve seats, so we should be good to go there. We're putting a little bit of assembly lube on the tips of the valves to help them get through the seal without tearing the seal. Also, it'll just provide a little bit of initial startup lubricant in the guides. I did give the valves a wiggle. I got a couple valves in here already. But I have given the valves a good wiggle to make sure we don't have any excessive sloppiness in our any of our valve guides. They all feel equally snug, so everything looks good there. I measured the valve spring seats, the valve spring shims, is what I'm calling them. I'm not really sure what that is, but they don't seem to be like a selectable size. They're all about 20 thousandths of all the ones I measured. So I don't think we have to do anything. We're going with stock springs. Oh, I got the cylinder all smoothed out on number 5, the damaged cylinder, and it actually turned out okay. There's definitely some scarring, of course. If I were to try to take off take away all the scarring, I'd end up removing a lot of material. But I did get all the high spots knocked down, and I think that's gonna be just fine. Everything is smoothed at the touch. You know, you can feel those little grooves, but it's not severe at all. Honestly, with the piston and rod package I have going in this, and with the stock springs, this motor's probably only gonna be safe for about 500 wheel. I think would probably be the max that it ever makes safely. And that might be pushing it too. It's definitely something we'll probably figure out. I already tried to just get a combustion chamber volume measurement using water and a syringe, and it seemed to be real close to the same 50 cc's that all the other ones measured up as. So I don't think we're gonna have any performance issues whatsoever with that. But I'm gonna get all these valves put in the cylinder head, and then we're gonna start measuring shims and getting ready to measure valve lash. Buckets, the shims removed from the buckets. I took measurements of each shim. So we have a pretty good range of thickness of shims here. And then I have my valve installed heights here that I'll use for reference to try to set up the thicker valves where they're needed and the thinner valves. Obviously the exhaust clearance needs to be a little bit greater than the intake. And then just anywhere I have, you know, a particularly short installed valve stem height, I'll use a thicker of the bunch that I have for the intake, and so on. So hopefully with this, we can get the cams installed, check our clearance with the feeler gauge, and not have to move around all the buckets, or, you know, we might need to order some different shims if need arises. So I have got the cams installed and went ahead and measured valve lash on all the cylinders. Just using my feeler gauge kit here. Basically all we're doing is sticking a feeler underneath the cam lobe between the bucket and the cam itself, and getting our readings that way. So what I figured out through those measurements, I got them all written down here, and overall not too bad, but you can see I put little exclamation points on things that are out of spec. The spec for the intake side is 6 to 10 thousandths, and on the exhaust side is 10 to 14. So we have some really tight valves on the intake, and we have some really loose valves on the exhaust. 4 of each on each side, which tells me we likely started with all the correct shims here. We just got them in the wrong places. These buckets did get mixed up and out of order just since I took the engine apart. So probably wouldn't have had to do all of this if I would have kept them all in the order in which they came out of, like kept them in their designated hole. I think everything would have been pretty good. But now I'm just gonna have to look at this. What I have written down is the clearance is this first number, and then the one in parentheses is the thickness of the shim that's on the bucket for that valve. So I'm just gonna kind of move some things around and see if I can find a way to move these 4 tight valve shims over here to tighten up the exhaust, and then vice versa. And I think I have all the shims here that I need to get things within normal tolerances. Okay, so one of the things I wanted to do is going to be to check the main bearing clearances using Plastigauge. Just make sure we have clearances within spec. We have new rod bearings, as you saw earlier in the video. Whenever we put the GTE rods in, we did install it with new rod bearings, and we checked the clearances on all of them, and they were all within a safe tolerance. So I pulled the number 1 main cap off already, and I got my Plastigauge down there. And let's see, we're gonna get our little Plastigauge gauge. I'm gonna try to get as good as possible of an image of this. So you can see it's right there, right about in line. Sorry, that glare makes it kind of hard to see, but right at about 0.038 millimeters. Now the maximum allowable spec for the mains is 0.060 millimeters. So we are well within that range. All right, rear main is out once again, like a brand new looking bearing. And this one is a little bit under 38. and a little bit wider than 51. So, you know, probably somewhere like 43 or so. Still well inside of the .060 that is permissible. All right, so today is a big day in our engine build process. We're gonna be putting the cylinder head.
You mean big night?
Yep, today is a big night because we're gonna be putting the cylinder head on top of the new JZ. So over here we have the cylinder head. I had the cylinder deck surface machined. I had the valve seats cleaned up as you saw earlier on cylinder number 5. I lapped all the valves, measured, installed valve height to figure out how we need to shim them. I measured all the shims out, got all the shims in their appropriate spacing for proper clearance. We'll double check that once we get the cams installed, but we can go ahead and get the head on the car. So my man Dub just put our ARP studs in here. They should all have the hole facing upward, and they do. So we're gonna get those run down. We have a Cometic MLS head gasket, and its thickness is, how thick was it? I can't remember. Here's the part number. It is a 51 thousandths. I threw some paint on the cylinder head. As you can see, it looks brand new. It's gonna match all our shiny bits there. So we're about to throw the head on the block. I already got the gasket on here and lined up. And what I like to do on these things before I stick them on is I'll just like to get barehanded with a clean hand, or relatively clean, and just rub the entire surface. And I'm feeling for anything sticking up, any little pebbles or metal shard that might have picked up sitting on the bench. I'll be able to detect any abnormality in the surface that sticks up very much. I'm gonna just go over the whole machine surface with a bare hand and just make sure it's all smooth and there's not any chunks of anything stuck to it that'll inhibit its ability to seal. And now I'm not gonna set it down on its deck again until it's on the engine. So now we'll carefully place it onto our head studs. There she goes. Get her fingers out of there. And bam. Oh, baby. She is looking right. Not too shabby. It's a pretty shiny looking head now. You can see how nicely it matches the color of all our other components down here. She is a good looking engine coming together here. It's gonna be super clean and tidy. And of course I got a whole bunch more cleaned up parts here that are gonna get installed too to just complement it even further. So we've got the cylinder head on the engine. I went ahead and hit it with the same aluminum colored engine paint that I did on everything else. So it's looking nice and fresh. Got the cams installed. Had to swap around a couple more shims to get everything within spec. But as of right now, all of the valve clearance is within a normal spec. On the exhaust side, we have everything between 10 and 14 thousandths. On the intake side, everything is within 6 and 10 thousandths. So 100%, we're good there. We don't need to order any more shims. We have everything we need. So that's all good. Got all the main caps torqued down, the cam seals installed, and everything is shaping up to be pretty good there. So got this in the mail today. This is our genuine OEM Toyota timing belt. And I got these painted last week. We're gonna go with the gold color. I might have shown that already. I already got the crank sprocket installed. So that's gonna look pretty nice. Should have the lower or the upper oil pan and lower oil pan tomorrow. We are doing a rear sump on this. This is going to be set up with the rear sump that was used in like this in the Supras. Those oil pans are getting quite expensive and hard to come by, but I went ahead and copped one because probably in all likelihood be putting this in the Datsun, which will require a rear sump. So I took the valve covers to the shop the other day and sandblasted them and got them all nice and clean. So I'm about to hit them with some paint. Last night I welded on these dash 10 aluminum bungs onto the covers. Those are going to be for our crankcase ventilation system. Originally the PCV valve goes in this one. It has a little rubber grommet. Just popped the grommet out and welded right onto that hole. So on this one it would have had this little elbow. This is real easy to get out and just grab it with some pliers, or I think I just used a crescent wrench and just started twisting it side to side and it slid right out. and then welded this in its place. So they're all welded up. We're not gonna need to do anything else with these covers to modify them. So we're gonna hit them with the same paint. What we're using is this Duplicolor engine paint. Here's the color code. This is just the aluminum color. There's also a cast aluminum color that's just slightly darker. Once we got the valve covers painted up, they'll be good to install, but first we'll put the timing gears on. We got our backing plate over here that needs to be cleaned up. And I'm just gonna really give it just a nice soaping with a brush. Install it here, and then we can put our cam gears on, tensioner, set timing belts installed. And tomorrow I should be getting that upper oil pan, so we'll flip the engine over and get that installed. That should be pretty exciting. We're going to proceed cautiously, but also we're not afraid to break things on this channel. You know, we're going to send this thing and make some stink. We're going to have a lot of fun with it, and if we break it, then it is what it is. But what we do hope to achieve is learning where the threshold is. Hopefully it won't be a mistake on our part that destroys it, and we can really find out what this piston and rod combo is capable of. So we do look forward to putting a little gas to this. We're going to be running E85 in this engine and a big intercooler and drag race only, 95% trailered to the drag strip type of application here. So I do think we can get a lot of smiles per gallon out of this puppy. But it is going to be a minute before that thing sees the Datsun, because I have another build coming up for the Datsun, which is going to be a Turbo 400 overhaul as a bone stock Turbo 400 out of a 72 Corvette. So I am going to be filming that as well, turning the bone stock Turbo 400 into a manually shifted trans brake transmission. So keep an eye out for that build video. Once I've got that, once we've got a torque converter, then we can start talking about putting this thing in the Z. Keep an eye out for some updates on the status of the 2J, the status of the Z, and follow along with the progress. And for those that don't know, we also have an IS300 that we drag race that has a 2JZ that I built in a very similar fashion to this one here. So make sure you keep an eye out for videos featuring our IS300, which is going to be on the channel here very soon. But that is all for this week. Thanks for watching. Like and subscribe. We'll see you next time.